Welcome to ECHO-JEE. Now we are continuing the chapter that is parabola here. In last session we discussed about various types of parabola which are having vertex as a origin here, and now we are coming to discuss about vertex has h comma k. Here different vertex, that is h comma k, and is it passing through axis, principal axis, that is x here. And in that the first one is the first type of parabola. Here two types are there and one more two types, and more two types are also there. Here minus and minus, these are the two. I am taking only positive signs of parabolas here, and those are two types here. In that first one is y minus k whole square is equal to 4a of x minus h. The standard form of parabola equation is y square is equal to 4ax, where it is having vertex is 0 comma 0, and now here the vertex is h comma k. So that's why y minus k whole square is equal to 4a into x minus h. Here in place of h, y, I am substituting k value, subtracting k value, here h here. This is the standard form of parabola equation when having a vertex is h comma k. This is the point here, and if you go into the diagrammatical representation here, let us take axis here. Coordinate axis I am taking. This is principal axis, x dash, and y dash. Here this is O origin, and here I am taking focus is some point, that is focus is h plus a. First of all, I am taking a parabola that is not passing through origin. Here it is a distance of some distance to the origin here. That distance is called h. This distance is called h here, and the point is h comma k. This is nothing but vertex v. And what will be the focus? I am taking at some distance. This is the focus S. Focus. This is S here, and the point will become here h. This distance is considered as a here. H plus a, and what will be the focus here? K here. H plus a and k. This is the focus. And when comes to here, this is the parabola. The diagrammatical representation of a parabola here, and the first point is this is the standard form of parabola when a vertex is having h comma k, and the vertex, and this is the vertex h comma k, and the next one is focus. Why? Because focus is h plus a here, h and k, the distance is origin to focus is h and k here, so that's why h plus k comma k. And the end points of latus rectums are latus rectum is nothing but the line which is passing through focus and intersecting two sides of a parabola. This is L and this is L dash. What will be the point here? A plus h comma k plus 2a. This is one end point here. Next plant a plus h comma k minus 2a. These are the two end points of latus rectum. This is L and L dash. This is the point for this one. And equation of this axis, this is the axis here. This is axis. Then what will be the equation? Then the equation of axis is here. This is x axis. So y is equal to this. Y is equal to k. This is the equation of this axis here. And the next one, equation of directrix. Here equation of directrix, h plus a is equal again h plus a. This is negative side of h plus a. This is directrix. This is directrix. Then the equation of directrix is will become, this is h plus a, then it will become x is equal to h minus a equation. This is the equation. This is h plus a distance. This is the h plus a distance here. So the equation of directrix is h minus a here, and the equation of tangent at vertex. Here this is a vertex. The equation of tangent will become like this. This is a tangent of tangent. Then equation of tangent is here h distance. Then it will become h is equal to x here. It is at distance of h, so that the equation will become x is equal to h here. And the last point, then the next point, seventh point is length of lattice rectum. This is the length of lattice rectum here. L dash is the length of lattice rectum, and vertex to focus, the distance is vertex to focus distance is a, and then the distance will become length of lattice rectum is 4 into vertex to focus. 4 into vertex to focus is a, that is nothing but 4a. This is the point here, and the equation of lattice rectum, this is the last point here. This is the lattice rectum. These are the points of lattice rectum. If you solve y minus y1, that is equal to y2 minus y1 by x2 minus x1 into x minus x1. In this formula you can substitute, or else directly you can say it is at a distance of h plus a. So it is at distance of h plus a. Then the equation of lattice rectum will become, equation of lattice rectum is h is equal to x is equal to h plus a. Why? Because here h and a, it is at distance of h and a, so that h plus a here. This is all about the points of parabola form here. And you can also conclude here, you can also conclude y minus k whole square is equal to minus of 4a x minus h also. Just reverse of this one, you can get the equations like all the points, 8 points here. And the next type of parabola is that is equal to x minus h whole square. X minus h whole square, that is equal to 4a of y minus k here. 4a of y minus k. This is the standard form of parabola. Generally x square is equal to 4ay. This is the general form of parabola. If vertex is having origin, that is 0, 0. If vertex is having h, k, then it will become x minus h whole square, that is equal to 4a into y minus k. This is the form of parabola when it is having a vertex, that is h, k here, h, k vertex. So this is the formula of equation of parabola here. And the next one, if you look at the diagrammatical representation for this parabola. Diagrammatical representation for this parabola is, this is a coordinate axis I am drawing here. This is x dash, and this is y dash, and this is origin 0, 0, and here it is x square is equal to 4ax in the form of x square is equal to 4ay, x square is equal to 4ay. Then the parabola looks like this one. This is a parabola, and this parabola is intersecting at principal axis. This is the principal axis, this is axis here. So this is nothing but vertex and vertex is having of h comma k. It is a distance of h here. So I am taking, this is a vertex, the point is here vertex h comma k. It is intersecting the principal axis, this is the axis at h comma k, and this point is completed. Next focus is s is equal to h comma a plus k, h comma a plus k, and here it is a distance of, it is this distance of a units here. So then the focus will be k comma h comma a plus k here, h comma a plus k. Here I am taking, this is k units, this is k units here h comma a plus k here, a plus k, the unit is a plus k here. It is a distance from origin to focus is a plus k. This is the distance here, focal distance from the origin here. And next, end points of lateral rectum. What is lateral rectum? Here the line which is passing through focus as well as intersecting at 2 points on parabola, that is L and this is L dash, and L is nothing but h plus 2a comma k plus a and h minus 2a comma k plus a. These are the end points of a lateral rectum. And the equation of axis, this is axis here, this is considered as a axis here, then this is the y axis here, then the equation of axis will become x is equal to h here. And the equation of directrix, what is directrix here? This is the directrix, this is directrix, is a distance of a units and k units, a units and k units. So the equation of directrix will become negative side of this one, so it will be y is equal to k minus a, negative side minus a and negative k here, so k minus a is your equation of directrix. Then equation of tangent at vertex, this is the equation of tangent, it is touching at vertex here, the line is passing through vertex and touching to parabola. This is touching to parabola, then it will become tangent of parabola at vertex, that is y is equal to k, this is y is equal to k here. And the seventh point, length of lateral rectum, this is the length of lateral rectum, it is at vertex to focus, the distance is a here, then the 4 times of the distance from vertex to focus is 4 into a, this is the length of lateral rectum here. And equation of lateral rectum, this is the lateral rectum, the equation, what will be the equation of lateral rectum? Equation of lateral rectum will become, this is a distance of a plus k, then the equation of lateral rectum is y is equal to a plus k here. This is the equation of lateral rectum, and this is all points about the parabola x minus h whole square, that is equal to 4a into y minus k. And here you can write one more parabola from this expression y x minus h whole square, that is equal to minus 4a into y minus k. This is one more type of parabola, this is looks like this one. This is directrix, this is principal axis, this is tangent of vertex, this is this is a axis here, and this is principal axis here, and this is parabola, this is end points of lateral rectum, this is the length of lateral rectum, this is the equation of lateral rectum, and all the points here, this is vertex, this is focus, this is directrix, all the points are there here. This is all about, and this is not passing through origin, this is origin here, this is origin. So this is all about the points of parabola here. Here some important parts of the parabola here. In the first one, the equation of parabola whose axis is parallel to 2 types. One is x axis and other is y axis. For example, if I am taking coordinate axis, this is x dash and y dash. So the equation of parabola whose axis is, this is for example I am taking this is an axis, this is an axis whose axis is parallel to x-axis. So axis, this axis is, one more axis I am taking, this is the axis is parallel to x-axis, parallel to x-axis, then it will be the formula of parabola is here, x is equal to a y square plus by plus c is equal to 0. C is equal to 0. This is the equation of parabola when axis is parallel to x-axis. In the same way, when axis is parallel to y-axis, then the equation of parabola is equal y is equal to ax square plus bx plus c. Here y square plus by plus c. Here it is in the form of quadratic. Here ax square plus bx plus c. Here it is in the form of, this is the parabola equation when principal axis is parallel to x-axis and the principal axis is parallel to y-axis. And the second point, the parabola y is equal to ax square plus bx plus c is symmetrical to the above line 2a. The differentiation of this axis, this equation will get 0. That is nothing but if you differentiate this, y is equal to ax square plus by plus c is equal 0 with respect to the x, dy by dx is equal 0, then 2ax plus b into 1, this is 0, dy by dx is equal to how much, 2ax plus b. This is the condition for symmetrical line. Symmetrical line is nothing but the differentiable for the parabola, then we will get the differentiable is equal to 0 of parabola, we will get the symmetrical line here. And the next point is the parabola x is equal to ax y square plus by plus c is symmetrical about the line, then it is in the form of x is equal, so the variables in y here, so I am derivating dx with respect to the y, then dy of ay square plus by plus c, derivating with respect to y, so 2y a plus b into 1 plus 0, so 2ay plus b is equal 0. This is the 2ay plus b is equal 0, symmetrical about the line, differentiation of x with respect to y is equal to 0 here. And the length of lattice rectum of a parabola ax square plus bx plus cy plus n is equal 0, then the equation of parabola is in the form of ax square plus bx plus cy plus n is equal 0, then the length of lattice rectum will be, so mod of c by a is equal to coefficient of y and coefficient of x square here. So modulus value of c by a, this is the length of lattice rectum, that is nothing but L dash. If you want to find the L dash here, that is the formula for here, modulus of c by a when the equation is in the form of ax square plus bx plus cy plus n is equal 0. This is the length of lattice rectum formula for the form of parabola equation. And the length of lattice rectum of this equation ay square plus by plus dx plus n is equal 0, then the length of lattice rectum will become modulus value of d by a. So similarly coefficient of x here, coefficient of x and coefficient of y square. So this is the length of lattice rectum, this is also length of the lattice rectum for two different types of parabola equations here. And this is all about this point here. And the most important one, the focal distance from point to parabola. For example, if I am taking a parabola, focal, this is a focus and point on a parabola P of x1 comma y1, and the distance here y square is equal to 4ax. In the if it is a parabola is passing through origin, this is a parabola passing through origin, and y square is equal to 4ax is in the form of y square is equal to 4ax, then the length of focal distance is equal to x1 plus a, modulus of x1 plus a. And in that same way, if parabola is having negative side, y square is equal to minus 4ax, then what will happen here? the parabola is like this. This is focus, this is point P. So the length of this one is x1 minus a modulus of, and this is about the second point, this is about the first point, and x square is equal to 4ay, and the next point is if the parabola is passing through origin, and the equation of this parabola is x square is equal to 4ay. So then the length of it is focus, and a point, it is focus is a point on parabola. The length of focal distance is modulus of y1 plus a. This is all about this point here, third point, and the next one length of focal distance when the parabola is passing through origin, and equation of this parabola is equal to x square minus 4ay. So this is focus S, and this is point on parabola. The distance between these two is modulus of y1 minus a. These are the four different types of parabolas and their length of focal distances here. This is x1 plus a, this is x1 plus a, it is in the form of 4 square, y square is equal to 4ax. It is x1 minus a, it is in the form of y square minus 4ax. y1 plus a modulus x square is equal to 4a minus is in the form of, and y1 minus a, it is in the form of x square is equal to minus 4a. These are the four different types of cases when vertex is having 0, 0, and each and every parabola intersecting at 0, 0 on a principal axis, that is called vertex here. And the next topic is double ordinate. Double ordinate is nothing but a line which is passing through a chord of a parabola, and it is intersecting at 2 points of the parabola. Here not L dash. L dash is nothing but latus rectum. You can take any values here. Latus rectum here, that is passing through focus, but it is not passing through focus. The double ordinate of the parabola is perpendicular to the axis of parabola. Here it should be perpendicular to axis. This is axis, and this is double ordinate. Double ordinate, always double ordinate is perpendicular to the axis, here. And the length of double ordinate, if you want to find the length, the distance of these two double ordinate points of double ordinate here, the parabola which is at a distance of p unit from the vertex, this is vertex V, and the length of the distance is here p from vertex to double ordinate on the x axis here, then that is 4 into square root of AP here. A is nothing but the point vertex to focus here, and the length is equal to A is equal to length of latus rectum by 4a. A is nothing but length of latus rectum is equal to how much? 4a divided by 4. 4 1 ja 4 1 ja. Then you will get A here. The length where A is a length of latus rectum by 4 here. And the final point is if theta is subtended by double ordinate at vertex of y square is equal to 4ax. Y square is equal to 4ax. If theta is suspended by the double ordinate, at vertex like this, at theta, this is theta here, this is also theta here, then the length of the latus rectum is, the length of latus rectum formula is 8a cot theta by 2. If you substitute theta, angle and a, where a is equal to length of latus rectum by 4, then we will get a. If we substitute a value and theta value, so angle suspended by at vertex is theta here, and theta a value will get the length of latus rectum. This is the length of latus rectum. This is all about the topic parabola and their different forms of parabola is having vertex is h comma k here.